Hi, everybody. Welcome to Lecture 15 in our series on the Trivium. That is the first three of the classical liberal arts: grammar, rhetoric, and logic. We are, at this point in the series, thick into our discussion of the logic of propositions. We're going to revisit the different kinds of propositions that we've already introduced earlier. You know, we've been dealing a lot with categorical propositions. And in this lecture, we're going to look at how to symbolize hypothetical proposition. So this is when you have a couple of different claims contained in a single statement. On the screen here, you have the chart that was introduced at the beginning of our discussion of propositions, outlining the three main kinds, or at least identifying them. Categorical propositions are what we have been looking at. We've looked at the A, I, E, O form of these, standard form of categorical propositions. We also mentioned when we introduced this chart the first time that modal propositions have to do with the mode or kind of tone of the proposition. Something must be true or something might be true. That falls beyond the scope of our discussion in this introductory series. Today we're going to look at hypothetical propositions and specifically how to symbolize them. So this will serve as a kind of introduction to logical symbols, which is not the main purpose of this course. However, the ability to symbolize propositions is really useful once you start doing more advanced kind of logical thinking. You don't have to go full mathematical on it in order for the symbols to be useful. So on this chart here, you see we have our three kinds: conjunctive, disjunctive, and conditional. So let's review a bit about those three kinds to begin with, to make sure we know what we're talking about. We're going to start by actually looking at conditional propositions. So as we have on the slide here, hypothetical propositions combine two or more categorical propositions using any of three connectives: and, or if then. And as we'll see later on in the lecture, there are lots of English words that you can use to indicate these relationships, but and, or, and if then are the most simple kind, and the kind to which a lot of those other kinds of phrasing can be reduced. So when you have different propositions, categorical propositions, and you want to combine them, you can use a symbol to stand in for each of those categorical propositions, because it's going to get cumbersome writing them all out all the time, right? So that's why we are symbolizing them. The image here, which is the truth table for the conditional if P then Q, is often talked about in this connection. So here P would stand for one categorical proposition and Q would stand for another. And the arrow indicates that you are placing these into a relationship. So the P here is what we would call, remember, the antecedent, and the Q is what we would call the consequent, right? So the antecedent comes first, the consequent follows, and you indicate their relationship with the arrow. So take the example here, and we'll take a little look at this truth table. If I study, then I will pass the exam. Right? So let's say that P stands for I study, and Q stands for I will pass the exam. So you're saying if P, if I study, then Q, then I will pass the exam. Well, let's take a look at the truth table. I want to know if the statement, if I study, then I will pass for the exam, is that statement taken as a whole true, right? So I write on the truth table here, there are two possibilities for P, and there are two possibilities for Q, right? Either P can be true or false, or Q can be true or false. So once you put these together, 2 times 2 is 4, you get 4 logically possible outcomes in terms of the truth value of this conditional proposition. If it is true that I study, and if it is true that I pass the exam, then we have, in our first line here, the statement is clearly true, right? Well, I did study, I did pass, it is true, right? If it is true that I study, but it is false that I pass the exam, well, then the statement taken together is false, because the antecedent was true, but the consequent is false. And this is notably the only case in which a conditional statement will be false. Conditional statements are always taken to be true so long as the antecedent is, so long as the consequent is true, right? If the thing follows, if the consequent is true, then it is true. Am Am I getting that quite right here? Let's see. So we have true, true, false. Let's go on to the possibility that P might be false, right? Now let's look at the fourth line here, actually. In that case, we have the beginning, the antecedent, if I study, is false, so I didn't study, and I will pass the exam is false, so I didn't pass the exam. So that's as obvious as the first line. If I don't study, I don't pass. The tricky line would be the third one here. It is false that I study, so I don't study, but I still pass the exam. Some other folks on YouTube have talked about this as a kind of vacuous truth, right? I can't really assess the overall truth of the statement because if the antecedent, P, is false, then the whole thing kind of falls apart. I mean, what am I even talking about? Like, it could be true that I pass the exam even though I don't study. That doesn't prove that the statement taken as a whole, if I study, I'll pass the exam, is false, and therefore we count it as being true. So when I was stammering a bit a moment ago, we can see that the only case in which the conditional statement, if P then Q, as in our example here, the only case where it's false is when the antecedent is true and the consequent is false. When P is true and Q is false. In all other cases, it's taken to be true. Right? So this is the kind of thing that you're able to do with logical symbols. So we have this little table, right? We're able to use that table to assess a whole variety of statements of this logical form. And that's what we're trying to get across today. So let's review here what we mean by conditional statements, and then we'll take a quick look at conjunctive and disjunctive statements before moving on to logical symbols. So a conditional statement, this is the most normal way of relating two categorical propositions. And as we've said, these are if-then statements. And what you can do is use a letter to stand in for one of the propositions. So you have a proposition that is the antecedent, it comes first. You have another proposition that is a consequent, it comes second, as in our example here, where E means the economy grows and R means tax revenue grows. You could say, if the economy grows, then tax revenue will grow. That so happens to seem like a true statement. Here we have the claim, if you are over 10 years old, then you are over 2 years old. It's kind of trivial in a certain sense, but this also does hold true, that if I'm over 10, then certainly I'm over 2. You can symbolize that by saying 10, if 10, then 2, using the arrow to connect the two. And the third one here, where G means you are good and L means you get a lollipop, we like our lollipops, then you have the statement, if G, then L. If you are good, then you will get a lollipop. There we go, conditional statements. We also have the other two kinds, and these are the only three kinds of hypothetical propositions. Conditional is the one we looked at, and next is conjunction. So conjunctions are formed, as we have on the slide here, when we combine two categorical propositions using the word and, or something similar that implies and, right? So in this case, take the example, Carlos is short and Sylvia is tall, right? If it is true that Carlos is short and it is true that Sylvia is tall, then I have taken together a true proposition, a true conjunctive hypothetical proposition. If it is false that Carlos is short, but it is true that Sylvia is tall, I have an overall false proposition, right? Because the idea is both of the categorical propositions have to be true. Both what comes before the and what comes after the and. Only if they're both true is the proposition taken as a whole true. Last kind are disjunctions. Now, disjunctions are formed when we put two categorical propositions into the same statement, as we have on the slide here, but we set them out as alternatives rather than combining them. So we have our example from our author Hauser. Either Augustine was a bishop or Anselm was an atheist. Okay, backstory, both Anselm and Augustine were bishops and they both believed in God. Therefore, it is true that Augustine was a bishop, but it is false that Anselm was an atheist. And you can symbolize this proposition, suggested by Hauser, with AG, and then you use the symbol V for or followed by an. So that is how to symbolize it. And in this case, it would be true because it is true that Augustine was a bishop, but it is false that Anselm was an atheist. So you have either a true statement or a false statement, in which case you could say, yeah, the true statement, right? Pick one of the two. The proposition, the disjunctive hypothetical proposition as a whole, only requires that one of the two be true, at least in an exclusive disjunction. All right, let's talk a little bit about symbolism, because that's going to be a main business in this lecture and in the assignment if you are completing an assignment that you are completing this week. So if you want to refer to a proposition, the standard letters to use are P, Q, or R, right? And those can stand for any categorical proposition. We get from this the old phrase, know your P's and Q's. This means that you're thinking logically. You have studied some logic if you know your P's and Q's. In the case of particular propositions, let's say there's a specific categorical proposition that you want to refer to, not just any one in general. You can use a capital letter, large case letters, I guess that would be capital letters, A, B, or C, and those are standing in for a definite proposition. And then we're moving into negation, right? So in the negation is indicated by a tilde symbol. So not A would be tilde A, the denial of proposition A. So if I say A is it is raining, but in fact it's not raining, I would say that not A is true. Tilde A is true. You can use parentheses in logic just like you use them in mathematics. Let's say you want to, you have like a more complex kind of proposition. You have a conjunction followed by a disjunction. You want to symbolize all of it together. You can put a portion of it in parentheses and then say, if all of this is true, or this one other thing is true. So it works just like it does in mathematics. The last one on this slide are disjunctions, and we've already said that the letter V is used to symbolize that. On the slide we have logicians sometimes distinguish the symbol for inclusive disjunctions from the symbol for exclusive disjunctions. So inclusive injunctions are where both alternatives can be true, and that means I could have one or the other or both. And that would be symbolized by a lowercase v. Whereas in the case of an exclusive disjunction, I must pick between one or the other. Either I'll go to the store or I will stay home. In that case, you'd have an exclusive disjunction. I can't both go to the store and stay home. But I could say either I will have vanilla ice cream or chocolate ice cream. If I end up having both and it's an inclusive disjunction, then that would still be a true statement. Last slide here explaining the logical connectives or symbols. Conjunctions often include the word and we'll see some other examples of that in a minute. You can use the ampersand, which is that little typesetter symbol that looks like the et symbol. Or you can also use a dot. And so if you're writing it out longhand, you'd often just use a dot. But if you're typing on a computer, it's more typical to use an ampersand. And the last one is what we've already talked about at some length. In conditional statements, the order of the propositions makes all the difference. So as we said, the antecedent comes first, the consequent comes second. It matters what order they're in. You're making an if-then statement. And in that case, you use an arrow pointing to the right. And this emphasizes, yes, that in fact the order matters. You can say if P then Q, or you can read this as P implies Q. So implication means here, if the first one is true, then the next one will necessarily also be true, if the proposition is true. We have here on our last couple slides something that you will have seen in Hauser's text. These are the symbols for various kind of verbal expressions of hypothetical propositions, because very rarely in life are you really going to come across like a formal logical statement of these things, right? More often you're just reading a text and you're trying to kind of figure out what the author is saying. So if an author says and or both P and Q or P but Q, although P Q, and then down the list here. However, nevertheless, yet, or yet, all of those are ways of expressing a conjunction. You're saying that both of the things that you're saying are true. In the last three lines here, we have ways of expressing a disjunction, which is very simple: or, either or neither nor. Either or, either or, pajama, pajama, who knows? That's Louis Armstrong, isn't it? Let's call the whole thing off. Our last slide here gives us some English phrases that express conditional statements. So the most straightforward one is if then, but you might just have if. The P and Q might have their order reversed. You can talk about implication. You can talk about entailment. You can say in the case that, or in the event that, or provided that. All of these are expressions that are used to indicate that you're talking about a conditional proposition. If you know that, you'll be able to deal with it accordingly. And so, friends, we're moving a little further into our discussion of the logic of propositions here. We're putting them together and we're using symbols largely because things are getting a little more complex than just, yeah, all S is P or something like this. I hope you find this useful and that you enjoy learning to symbolize your own propositions.